So the idea of a Fourier series is that we can write any periodic signal as a weighted sum of complex exponentials having some fundamental frequency. So to write out the definition, it looks like this. So we have S of t, just denotes some signal in the time domain. It's equal to a sum. That's a bad sigma. The sum from k equals minus infinity to infinity of c sub k, which I'll talk about later, that's the coefficient of the term, times e to the j 2 pi kt over big T. Let me just make sure I wrote that correctly. I don't want to. Yes, okay.
Okay.
So let's break this down.
All right.
We have some signal, and the way we find the signal is it's a sum of some complex exponentials.
Okay.
They're multiplied by some term c sub k, which can be complex.
Oh, okay.
So
these coefficients could be real or they could be complex.
Yes.
Okay.
Mm-hmm. And we sum them from minus infinity to infinity. Some signals will actually have an infinite number of coefficients, but oftentimes there'll be a finite number.
Okay.
This j is what we talked about, the square root of negative 1. And this comes from Euler's identity, because this really breaks up into sines and cosines.
Right. Okay.
This 2 pi is just nice to have because I don't know how much physics you remember, but like it just makes it so that the frequency is 1 over big T. So
Okay.
don't worry too much about it.
Okay.
It just makes the math nicer. K is this term we had here.
Uh-huh.
And little t is the time variable.
Okay.
And big T is the period.
Yes. Okay.
So this k over t term is really a bunch of frequencies.
Okay.
Right?
Okay.
So we start with 1 over t, 2 over t, 3 over t, and they're multiples of the fundamental frequency, which is 1 over t, big T.
Right. Okay. So just for everybody at home, based on my rudimentary memory of introductory physics, the reciprocal of the period of a wave is the frequency of the wave, right?
Yeah.
So this is the frequency, this is the period. They have a reciprocal relationship. Okay,
Right.
good.